right, so let's jump into our first example, which, I'm not going easy on you here. This one's actually kind of gross. So the first thing you should know about finding antiderivatives is a couple things we're not going to know how to deal with, and one of them is quotients. So whenever you're finding antiderivatives, you can't have quotients or products, which we'll get to in example 2. But for the sake of this one, it's the quotient part that's a problem, right? So basically that means I have to find a way to rewrite this function without that fraction. And as you can see, I gave you one where there's 2 terms in the numerator, and that means we'll be able to split it up into 2 separate fractions. So let's go ahead and do that first. Okay, so we've split the fraction, and now we're going to simplify and try to write things with powers if possible, so that we can think about our power rule and how we're going to undo it. So the 4 sine x, there's only so much I can do there. Not really able to clean that up. 2x over x is simply a plus 2. And then if we think of exponents here, right, this would be x to the 1/2 over x to the 1. And if you think about your power rules, when you divide the same base, you subtract the exponents. So x to the 1/2 minus 1 would become x to the negative 1/2. Okay, so now it's time to take the leap into asking ourselves, what do I derive in order to get what I currently have? So basically, what is sine x the derivative of? I take the derivative of something and I get sine. And I know sine and cosine have a lot to do with each other, so I'm at least going to start with that. But I'm thinking, okay, if I'm working this direction, if I take the derivative of cosine, I get negative sine x. And I don't see a negative, so I need to kind of counteract that. That means I must have already had one. And then the 4 is a constant multiple, so it would not change, right? And you can always sit here when you've written an antiderivative and quickly derive it in your head and ask yourself, if I derive negative 4 cosine x, will I get back positive 4 sine x? And in this case, the answer is yes. Okay. Now, what do I derive and get a 2 from? That's simply 2x. That one's not too crazy. X to the negative 1/2 is a little bit harder to think through. So let's just take a second and think about if you were deriving, right? So let's say I have x to the positive 1/2. If I derive this, I know that this power comes down front. And then there's a minus 1 from the original power. And that is the derivative. So if we're undoing that, we're thinking, okay, instead of a minus 1, I'm going to need a plus 1 added to the power. So in this case, that would be x to the positive 1/2. And normally when I derive, I get this multiple out front. That was the old power. But I don't have it here in the derivative, which means I must have somehow already had that as a divisor. Let that sink in for a second. So I know that this is kind of the process of what I do when I derive something, right? And maybe it would be more helpful if I just jotted one down that wasn't a beautiful fraction. Right, like x squared would become 2x, well no, that's boring too. Let's do x to the 4th. That would be 4x cubed, right? So if I start with 4x cubed and I'm anti-deriving back, I add 1 to the power, right? That gets me to the x to the 4. And I see that new power as a multiple out front. So if I don't actually see it on the antiderivative, it means I was already dividing by that new power. We're going to spend a lot of time practicing this in class tomorrow, so, like I said, this is a pretty ugly one to start off on. Don't get too nervous about it. But basically, you're going to, instead of multiplying and subtracting a power, we're adding and dividing. We're doing the inverse steps. Okay, and then we're going to use the notation. If we're starting with a regular f, the antiderivative would be a capital F, right? And then, of course, do not forget the plus c as part of your answer. Oh, hello. Okay. Of course, we could clean this up a little bit, right? If I divide by 1/2, if you really would rather to just write that as a times 2, that's actually preferred. Okay, so you could rewrite that as that form as well. And actually, if you wanted to be fancier, x to the 1/2 is square root x. All right, I'm done, I promise. All right, let's look at example 2. Oh, there's that square root. Okay, so the other thing I mentioned at the beginning is still true. We can't have quotients or products because we don't, remember the product rule is pretty complicated, right? And undoing that is something you don't have in your toolbox, and you won't until you go to BC Calculus. So we can't have products. Okay, so if you do, you need to find a way to rewrite it. So let's do that first. So I'm just rewriting, I'm not anti-deriving yet. So that's really x times x to the 1/2. If they have the same base, we can add those exponents. So that's really x to the 1 plus 1/2. So 3/2. Perfect. Okay. And so if we're now going to anti-derive this, the antiderivative of f prime of x is simply regular f of x. And then this is kind of what we were just practicing. So thinking about undoing the product rule, the power rule. Normally we would subtract 1 and multiply. Now we're going to undo that. We're going to add 1. So that would give me x to the 5/2. And now we're going to divide by that new power instead of multiplying. Okay? And so if you want to write that a little bit prettier, you could simply say, what is that, 2/5 x to the 5/2, and then plus c. Really should be in both of those. You could write either as an answer as far as class goes tomorrow, but they're definitely going to want you to make it as pretty as possible, so we don't typically leave them in this form as a final answer. All right, last example. This one's actually kind of straightforward. We don't need to rewrite this one at all. We can just jump straight in. So what's the antiderivative of negative sine x? And that one's actually just really nice for us, right? That's going to be cosine x. And then the antiderivative of plus 2 is plus 2x. And then, of course, our plus c.